Hello friends, welcome to Jija Academy. In today's limit session, we are seeing the trigonometric limit when variable tends to non-zero. Now, as we already assume that limit x tends to a, f of a always exists. So, limit x tends to a, f of x is equal to limit x tends to right hand side limit of f of x is equal to limit h tends to 0 f of a plus h. This is the right hand side limit. So limit x tends to left hand side limit of f of x is equal to limit x tends to right hand side limit f of x is equal to limit x tends to a f of a, and we are using this in our problem. Now there are two formulas. First one is a limit x tends to a sine x minus a divided by x minus a is equal to 1, and second formula is a limit x tends to a tan x minus a divided by x minus a is equal to 1. So these both formula we are using in our problem. So we are starting first problem, that is limit x tends to pi by 2, that is a non-zero, sine square x divided by pi minus x whole square. Now here we are putting x is equal to pi plus h, that is a positive right hand side limit. So limit h tends to 0 sine square pi plus h divided by pi minus h whole square. So here we get limit h tends to 0 sine square h divided by h square, and we know that limit x tends to 0 sin x upon x is equal to 1. So we are using this formula. We get here the answer is 1. Moving to the next problem. Next problem is a limit x tends to pi by 2 cos x divided by pi minus 2x. So here again we are using here right hand side limit. So limit h tends to 0 cos pi by 2 plus h divided by pi minus 2 pi by 2 plus h. So here limit h tends to 0 cos pi by 2 plus h is nothing but the minus sign h, and here pi minus 2h. So we get here limit h tends to 0 minus sin h divided by minus 2h is equal to 1 upon 2 limit h tends to 0 sin h upon h. So this terms is equal to 1. So we get here answer is equal to 1 by 2. So answer is equal to 1 by 2. Moving to the third problem. Third problem is limit x tends to pi by 2 pi by 2 minus x tan x. This is the important problem. Here limit h tends to 0, pi by 2 minus pi by 2 plus h tan pi by 2 plus h. So we are solving this limit h tends to 0, pi by 2 minus pi by 2 minus h tan pi by 2 plus h is equal to minus cot h. So we get here limit h tends to 0 minus h into minus cot h. So we get here limit h tends to 0 h into cot h. So for cot h we can write tan h 1 upon tan h. So limit h tends to 0 1 upon tan h upon h, that is a 1. Answer is a 1. So we get here answer 1. Moving to the next problem. Fourth problem is a limit h tends to infinity 2 to the power n sin b divided by 2 to the power n. So here limit h tends to infinity 2 to the power n sin b upon 2 to the power n. So we are writing here limit n tends to infinity sin b upon 2 to the power n divided by 1 upon 2 to the power n is equal to limit n tends to infinity sin b divided by 2 to the power n divided by b upon 2 to the power n into b. So we get these terms is equal to 1. So 1 into b. So answer is a b. So our answer of this problem is a b. Moving to the next problem. Next problem is a limit x tends to b sin x minus sin b divided by x minus b. We know that the formula sin a minus sin b is equal to 2 sin a plus b, a minus b divided by 2 cos a plus b divided by 2. So we are using here that formula. We get limit x tends to b 2 sin x minus b divided by 2 and cos x plus b divided by 2 divided by x minus b. So here 2 limit x tends to b 2 into sin x minus b upon 2 divided by 2 x minus b divided by 2 into cos x plus b divided by 2. So this will So here we get limit x tends to b sin x minus b divided by 2 x minus b divided by 2 into limit x tends to b cos x plus b divided by 2. So this term is a 1 into cos b plus b divided by 2. So cos 2b upon 2. So answer is a cos b. Cos b. Answer is a cos b. If you like the video, please like and subscribe the Jija Academy. Thank you.